Okay, hello, good morning. Hope this comes into focus. Okay. Today we are solving equations, we're solving quadratics, but we're not going to use inverses or factoring to solve necessarily to begin with. Okay, there we go. Fortunately, I have to move this out here. Okay, so for example, say I gave you, now I don't have notes for this in your packet because I really didn't like the notes because we're going to go so gradually slow that it's going to be easy for you to do this. The examples in the book just jump way too fast to a harder example. I think you're going to be a little confused. So let's just start with examples I came up with. For instance, x squared plus 6x plus 9 equals 36. Okay, how would you solve this equation? Okay, so the former way that you would do it is you'd bring everything to one side. When you subtract 36, you're going to get a negative 27. So this is how you would normally solve it. You would factor, and you'd say, all right, what terms multiply to 27 yet give you 6? Well, I know a 9 and a 3 will give me a 6. The largest of the terms is going to be the positive, so we can get that 6. And then when I use the zero product property, it says if a product equals 0, one of the factors can be set equal to 0, and then you can solve. So the beauty of math is you can check your work. If I substitute negative 9 in here, I'm going to get 0. If I substitute 3 in here, I'm going to get 0. So your answer should be negative 9 and 3. Well, another way we could have solved this is to factor to begin with. And the reason why I can do this is because these are a perfect square. A perfect square is, or a square, is when it's whatever factor, x plus 3, 7, 5, and it's being multiplied by itself. So 25 is a perfect square because 25 is 5 times 5, and 100 is a perfect square because it's 10 times 10. So these are squares. It's x plus 3 times x plus 3. So I can condense it, and then I can just use inverses to solve. So the title of this chapter is called Completing the Square. So in this chapter, you're not going to necessarily have both, but you're going to complete it so you're able to solve. So we're starting with an easy example where you would have gotten your solutions this way. Now I want you to factor, condense, because you have the same thing twice, and solve. Well, I have to get rid of this 2 by taking the square root. Okay, you're going to get x plus 3 is the positive and negative square root of 36, which is 6. So positive and negative. Now we're going to get x equals negative 3 plus or minus 6. Because you move 3 over to the other side, now it becomes negative. Now be careful, make sure you change that sign. A lot of students forget to change it and their answers are off. So now you're going to have negative 3 minus 6 and negative 3 plus 6. So your solution is negative 9 and your solution is 3. Numbers are pretty cool. Okay, I want you to use this method with this example. I want you to try x squared minus 12x plus 36 equals 25. So go ahead, pause the video, and try solving on your own. You should have gotten 1 and 11. All right, we're going to try this again, but with maybe not as nice of numbers, just to give you more practice. So that's your first example. Your second example, like I said, just write this on a piece of paper, is going to be x squared minus 10x plus 25 equals 27. Okay, well, I can factor this to be an x minus 5 and an x minus 5. I couldn't use this method if I didn't have the same things twice. So x minus 5 squared. Okay. And then take the square root of both sides. And then move 5 to the other side. And I know 27 is 3, 3, 3. Have a pair bring it out. So it's 5 plus 3 root 3. And it's going to be 5 minus 3 root 3. These are the exact solutions. I mean, they're not pretty, but they're exact. You didn't round. When you get a decimal, that's not the exact solution anymore. You are rounding. However, I believe in the textbook, they ask you to round to the nearest hundredth or something like that. If they don't ask you to round to the nearest hundredth, or if they don't ask you to make it exact, you can put your answer however you want. Unless you know what they're asking for, it's your decision how you write your answer. So I want you to write it in decimal form to the nearest hundredth. And I have the answers, but I'll show you on the calculator. You would write 5 plus 3, and then you go second square root 3, enter. Okay, so your first answer is about 10.20, and then because you have to round to the nearest hundredth, and then your next one, 5 minus 3 root 3, is negative 0.20. Be careful. A lot of students get their answers as 10.2 and then immediately write negative 10.2. No, it's not necessarily going to be straddling that y-axis perfectly. So you have to make sure that you have the correct solutions. So I want you to try now using the same process. X squared plus 8x plus 16 equals 20. Okay. I want you to pause the video, try it on your own, and then play it back. Okay, so your answer should be 0.47 and negative 8.47. Okay, as you're doing these, whether it's homework or whether it's notes, in class, when I say, do you have any questions? People just kind of look. I think we're forgetting if we even have questions. So as you're doing things, make notes. Like put a star beside it or a circle or write the question beside it because it's hard to remember the next day what we needed help with. Okay, let's solve this equation. Well, factors of 9 are 3 and 3 and 9 and 1. Neither give me 16. Eesh. Okay. That 9 is no good to us. It is not beneficial right now. So we can't remove it, but we can push it off to the side. I left a blank space here because I want to put a number in there that will give me the same thing twice. Well, what number am I going to put in there? So let's look at the pattern. When I had 6, it was 3 and 3. When I had 12, come on, get in focus. When I had 12, it was 6 and 6. When I had 10, it was 5 and 5. When I had 8, it was 4 and 4. So we're going to cut that number in half and then square it to get 16. We're going to cut this number in half and we're going to square it to get 36. We're going to cut this number in half and square it to get 25. It's the same thing here. We're going to cut this number in half, and then when you square it, that means we would have had to have added 64. And we can just do that because it's an equation as long as you do it to the other side. So let's recap. I want to solve this equation that 9 is not beneficial to factoring a perfect square. I need the same thing twice. So I move the 9 off to the side. I need to create a constant, a c. So I take whatever my b value is, which was 16. I divided it by 2, 8, and then I squared it, 64. So that's what I added to both sides. Okay, so now we're down to x plus 8 squared equals 55. Okay, these aren't going to be the prettiest numbers, and that's okay. And then you take the square root of both sides, and then you subtract 8. And it's the same process. We're just going very gradual with our changes, so it feels familiar. We can follow easily. I'm just going to make it to the nearest decimal. So this is going to be negative 16.5, and this is going to be 0.54. Okay, so I had to create the constant in this one. I had to create the constant, okay? Example 4, or a you try. I should have wrote you try. You are going to do the same thing. You are going to be given x squared plus 6 minus 16 equals 0. I want you to move that 16 off to the side, create a new constant, and do what I just did. Pause the video and go ahead. Okay, so you should have gotten negative 8 and 2. You didn't get crazy decimals because if you were to get pretty answers, that means that this originally just could have been factored. It wasn't going to be a perfect square, but it would have been factored. But that's not completing the square. We just completed the square. So this lesson is solving a quadratic by completing the square. So let's write that down. We're solving a quadratic by completing the square. Okay. All right, there's one more that I want to go over. what happens if we don't have a positive or a 1 in the front. So for instance, let's try 2x squared plus 16x plus 7. Okay. So we know that that 7 is not helpful. We're going to move it off to the side. That we need to create a number that is going to be helpful. But I need to get rid of this 2. So I'm going to get 2 parentheses x squared plus 8x something equals negative 7. So I take that 8, I divide it by 2, and I square it. So that's going to be 4 squared, which is 16. So if I add a 16 to one side, I have to add 16 to the other side. However, 2 times 16 is 32. So I have to add not 16, but 32 to the other side. So now I can simplify and solve. Divide both sides by 2. So you're going to get 12.5. Okay, take the square root of both sides. It is not proper to write this, but I'm just doing it for the moment because we're going to make decimals anyway. If that was my final answer, I would make that into a fraction and make it pretty. I'll show you how to do that in a minute. Okay, so I'm only keeping it in that form because I'm eventually making it a decimal anyway, so it doesn't need to be proper. Okay. And what was it? Okay, so I would never leave a square root like this. Well, 12.5 you can do here equals 12.5. Hit the math button. I want to make it fraction. It's already highlighted. Enter. That's the same thing as 25 over 2. I'm sure you guys could get it. I'm sure you guys could have done 12 and a half and then made it 24 over 5. Okay, so if I were to leave it like that, or just go back a step and see that, I would take the square root of the top, I take the square root of the bottom. You would get 5 radical 2, but you can't leave it like that because you can't divide by something that never ends. So we're going to rationalize the irrational denominator by multiplying by the square root of 2. So you would have gotten 5 root 2 over 2. So it would have been negative 4 plus or minus. That's how you leave it. But if you're making a decimal, that's how you leave it. Okay, this isn't going away. You do this in calc, you do this in pre-calc, you do this in calc 2. It doesn't go away. So just might get used to it now. All right, and I want you to try one on your own. Last example. Okay, you're going to try 2x squared plus 12x plus 13. Okay, I want you to go ahead and use the same methods that you did with these notes on your own, and then come and watch the video. I put in a 9, so I have to put a 9 over here, but did I really put in a 9? I really put in an 18. So 2 ways you can do this. X equals -3 plus root 5 over 2, and x equals -3 minus root 5 over 2. You cannot leave it like that. It would be the square root of 5 over the square root of 2, which we're going to rationalize. So you could make your answer -3 plus root 10 over 2 and -3 minus root 10 over 2, or you could just put it in decimal form. Okay, your homework is bookwork. I believe it's on page 250. It's written in Google Classroom. The answers are in classwork in the homework answer section. Like I said, you need to start starring things, and when you come in, you're writing on that chalkboard the numbers that you want to go over. Okay, if you have any questions, feel free to email me.